Good morning. My name is Navjot Singh Gill and I'm an application engineering with PLM Solution. I want to welcome you to PLM Lunch Bytes series. These series are designed to briefly explore capabilities within Solid Edge that are often overlooked. Today's session will be on Simply Motion. If you have any questions regarding today's session, please write them down and send them via email. We have a lot of you on the line today, so you'll be in listen-only mode so that we don't hear your feedback from speakerphones, etc. Once again, today's topic is Simply Motion. Simply Motion is the quickest and easiest way to perform motion simulation on your Solid Edge assembly. That does is a assembly specific command. You can generate animations of your moving assemblies, or you can use Simply Motion to check interference as the assembly moves through its full range of simulated motion. Now, one important concept inside Simply Motion is called constraint mapping, and basically what it does, it creates joints depending upon the type of relationships you have between different parts inside the assembly. So in this slide, you'll see that it creates a joint. The name of joint is Revolute, and it's a combination of two relationships, and those relationships is a mate and axial align. So it automatically creates that for you. That's one way of using Simply Motion, automated motion. The other one is manual option, and we'll cover both options today. So what I'm going to do is open this assembly, and inside tools there is a command. There's a group called environs group, and inside this group you can click on this motion, and that will launch Simply Motion. So the first screen which I get after launching Simply Motion, it asks us to add new ports. So here we have to decide which way we are going, whether we are doing an automated way or manual way. So if I press yes, so it's going to automatically map all the constraints, the assembly constraints, and create joints. So as you can see that it maps all the planar and axial relationships. So I'm going to dismiss this dialog box, and you'll see that all those joints, we get some graphic feedback about those joints. At the same time, you'll see what it does, it divides the total number of ports into two groups. So first group is the moving ports, and the other one is grounded ports. So in the ground port, you'll see there is one port, the shaft is inside the ground port. The way Simply Motion works is if the assembly has some ports and those ports are grounded, with the grounded relationship, what it does, it grounds that port inside the Simply Motion. So it's looking for that ground assembly relationship on that specific port. So if it doesn't find a ground relationship, what it does, it puts that port inside moving ports group. And also you can see that it automatically generates all the joints. And let's look into different joints now. If I click on the Revolute, you'll see that it tells us that it's been created between these two parts, and what all relationships were used in order for this joint to create. So similarly, there are other joints like axial, so already it mapped with the axial relationships inside the assembly, right? So that was the automated way of creating motion. So here what I'm going to do is I'm going to open another assembly, and we will look into another way of creating motion, and that is a manual way. So in order to get a better understanding of different type of joints and the way they are created and the functionality aspect, I'm going to create some motions on this simple assembly. So we do the same workflow. I just select the motion. Instead of saying yes, I'm going to say no, because I want to manually create those joints. And you'll see that these two groups, motion parts and the ground parts, they don't have any ports, so it didn't map any port. So now what I can do is, there are multiple ways, multiple workflows of creating this. Either you can click on any of the commands inside the ribbon, or if you like the wizard style, like which has all the steps. So what you can do is use this command called Motion Builder. So what it does, it opens a window and it tells you different steps. So all I have to do is go from left to right, assign proper parameters, and I can create my motion. So in this case, I can select the unit. I can assign gravity if I want to on any of the axes, X, Y, Z direction. And here I can specify the port. Now, the way we can specify port is just by clicking on the port and then dragging it onto the window. Like in this case, I want to ground this base plate. So what I'm doing is placing it on the ground port. So that's why that tells system it has to ground that port. Same way I can select another block part and then move it inside the moving part, similarly with the cylinder too. So by doing this, I've told the system manually that what all ports I want to be grounded and what are I want to specify as moving ports. The next step is joint, and this is a very important step. Here we'll be specifying different type of joints. And the first joint we are going to cover is called a translational joint. So the motion which I want to create here is this pin is moving inside the slot. So what I'll do is I'll just select translational joint and then say add joint. So it opens another window, and here I have to specify which parts I want to select. So in this case, I want to select the cylindrical pin and the base port. So the third step is select location. So what it does, it's going to place that that joint on this specific location. This location can be anywhere on the moving part. And then the next step is select direction. In this case, it's going to be a linear direction. So I'm going to grab, I can grab any edge. And you'll see it creates this graphics of a translational joint. Now, in order to enter some parameters, I can tell Simply Motion what type of motion type I want. So there are different type of motion, and they are free, displacement, velocity, and acceleration. As the name says, everything else is very self-explanatory other than this free motion. What is free motion? If I create a motion between two parts, A and B, and I want A to move, but that movement will be decided by the way this A part is interacting with some other part, that is C part. So by making a free motion, I can specify the type of linear movement. So in this case, what I'm going to do is keep it as displacement, because I know the distance inside the slot. So and the next step is assigning a function. Now there are different ways you can assign the function. What it does, it looks for a graph. That graph is going to be a time displacement graph. Whether you want a straight line, that would be a constant. If you want a step, harmonic, or a spline function. So we're going to cover all of them one by one. First, we'll look into this constant function. Since I know the displacement, what I can do is give it a value of 90 and hit accept. And now I can run the simulation. And you'll see that it moves on the right-hand side. So that was the displacement. Now maybe we want some more flexibility in terms of motion. So what I'm going to do is change the type of function inside this translational joint, and that function type in this case would be a velocity function. And now I can give it a value of say 10 millimeters per second. Now since this is velocity is related to time, so what I'm going to do is inside the simulation time I can give it a 9 seconds, so that it runs on 10 millimeter per second for 9 seconds and covers the 90 millimeter direction distance. All right, so that was velocity. So now going back to our motion, there's another type, and that type is called spline function. So what I'm going to do is give it a displacement, and at this time now I want a spline function. Why do I need a spline function? Because I want more control in terms of the movement of the part. So I can give it a value for timing. So in this case, I'm telling the part to move for this specific time. So and also giving it a value for displacement, and I can give it any value. In this case, I'll say 90. Now since I given it a value, I can hit OK, and then we can run the simulation. So this would be a more control, and speed will be dependent on the values of the spline function which you entered. Now what I'm going to do is just change the spline function a little bit in order to get a reciprocatory type of motion. So what I'm going to do is just enter some more time here, give it 12 and 14, and here I'm going to give it a value of 50. So now this is descending and 0. So what it's going to do is move from left to right and then from right to left. So I can give it a time and I can change it from 9 to 14. Since I change this, you'll see that it moves on the right and then moves back to left. So that's a use of spline function. Now the next thing which I'm going to cover is how to check the interference. So for that, what I'm going to do is change this back to displacement and change this value from 90 to 95. So all I'm doing this is I'm trying to create some sort of interference with the base plate. So there's an option for interference, and I can check the interference, go to the options, and there are different type of interference you can check. You can do interference on first contact, or you can do a minimum clearance. In this case, I'm going to do all interference. I'm going to select these two ports and then click on this Find Now. Now you'll see that as the motion, with motion, you can find interference at a particular time. Now if I move this down, you'll see that it gives me different frames and the time, and it tells me the port, what all ports I want. So, and also gives you the volume, so what all volume was covered inside of interference. So now I can so that's how you can find interference inside motion environment, right? Next thing I'm going to cover is next thing we will do is use a concept we have learned here in order to get motion in a more complicated assembly. So in this case, I'm going to open this this assembly, and this motion I have already created. So what I'm going to do is just to run this motion, and then I will cover how to create these type of motions. So all I will do is just go to motion and then click on the simulate. And you'll see that it moves a block on the left, and at the same time it goes, the tool goes down. So here what I've done is I've used translational joints in 3 assemblies. So I'll show you a little bit how I did that, and for that I'll just open that assembly. And all right. So the workflow is very simple. It's similar to what I've done before. So all you need to do is go inside the builder, motion builder, and inside the joint you can specify the type of joint you want. In this case, I want a translational type of joint, and now I can select the type of the part or assembly I want. In this case, I want this assembly to move, and then I can select the other base plate, and then I can select the location I want to place a joint on. So in this case, the location is going to be from left to right. So in the motion type, I can give it a displacement. In the constant, in the function, I want to use a spline function. In this case, I can enter all these values manually, but I want to import all these values from a text file. So there's an option to for loading data from a file, and I can select the file, hit open, and that will map all the data points. And now I can hit accept, and in order to test this, what I will do is first, as you can see, that direction is from left to right. Maybe I want to change the direction. So inside the definition step, I can click on this direction to toggle the direction on the other side, hit OK, and now I can run this simulation. All right. The way I want to do is like I want this part to drive the motion on the bottom part. So what I will do is I'll go back to joints and create a new translational joint, this time between a different port. That is going to be this port and the port on the base, and I can give it a direction. And now again I would do a displacement, spline, and load data from another text file and then simulate. So again, as you can see that the direction is not right. I can correct that just by going inside the joint and by reversing the direction inside the joint. So for that I have to delete the result, go inside joint, and the properties, I can toggle the direction from right to left and hit OK. And now I can run the simulation. Now you will see that it moves from right to left and go back. So the reason why it's going back is because of the points which I arranged in a descending order inside that spline function, right? So similarly, I can create another translation joint. In this case, I'm going to use this tool as a port. So what I'll do is go inside joints, add a new joint with the tool and the base plate, and then give it a direction. In this case, I want a displacement, spline, loaded from text file, and check the direction, hit OK, and run simulation. So that's how I created the simulation with the help of translational joints, 3 different translation joints, and with the help of spline function. Right. So next part, what I'm going to do is show you some more different type of other joints. So till now, what we have concentrated more on translational joint. So now what I'm going to do is open this file, and with this assembly, we'll cover some other joint information, such as spherical joint, revolute joint. Right. Finish. So the steps are very similar. I start simply motion, and then I go into motion in this builder. Now I have already defined different parts in this assembly as moving parts and grounded parts, and all I have to do is I've also defined some joints here, and the list of the joints are like some axial joints and revolute joints. So what we will do now is create a revolute joint. The motion which we want to create here is rotate this knob to a certain degrees so that this linkage assembly follow the motion of this rotation. So for that I need a revolute joint. What is revolute joint? It's just like an axial, like 2 cylindrical surface. I want to rotate at a certain angle, so I use this revolute joint. So I can click on add joint, select the parts which I want to select. In this case, this knob. And this part. Again, giving it a location, I want to select this inside edge and give it a direction. In this case, I'm going to just select this cylindrical surface. And now I can give it a velocity. In this case, it's going to be an angular velocity because it's a rotational type of joint. And the next joint I'm going to define is called a spherical joint. What it does, it rotates the parts in 3 axes. So I'm going to use this joint on these 2 parts, the link port, the crankcase. I can give it a location. So I'm going to select this sphere. And then give it a location, a direction. That's going to be this edge. And then in order to run, all I have to do is just let me move this assembly a little bit on the right side. Now all I have to do in this case is let me change the direction on the knob to the other side, this side. All right, so now I can hit simulation and simulate, and you'll see that it works. So if I want more revolutions, all I have to do is just change the time. In this case, I would do it 3. And I can also increase the frames. So from 50, I'll just keep this as 200 and run the simulation one more time. All right, we just saw different types of joints like translational, spherical, revolute joint. Similarly, there are other types such as locked, where you can lock the rotation, lock the movement of a part. And the next thing what I'm going to show you is this calculator assembly, and I've used a step function in order to get that animation, and you'll see this is different than spline. So what I will do is I run the simulation, and the way I've done this, it will open the top flap and then I can reverse the motion. So if I hit simulate, it's going to first launch the switch and then open this open the top flap, and if I want to reverse this, I can just click on this reverse replay, and then I can show it how it can close. So once you have motion defined, what you can do is you can create animations and you can save this as a AVI. So those options are inside this animation. All you have to do is hit this create animation, and that will create a small AVI. And you can also toggle this movement in order to change the frames and the time. All right, that's all I have as far as Simply Motion is concerned. Just a quick recap of what we covered today. We covered different type of joints: revolute joint, cylindrical, translational, spherical, and we showed how we saw how we can change the function from spline, constant, end step in the end. And we can also specify things we didn't cover was initial displacement. If you have a motor, electric motor, and you want a shaft to be at a particular rotation before the motion to start, you can enter that angle value inside this initial displacement. So before it starts motion, it will take that initial displacement. Similarly, we can have an angular velocity, and this slide tells about what all different functions, like step function. Now, if you have a graph between time and displacement in this order, you can use step function to give it an initial value, final value, and give it a time, the start time and end time, and you can have that type of step motion. In case of harmonic motion, you can give it an amplitude, frequency, time, and this is what we covered, like spline functions, where you can enter different data points in time, and we covered in like distance, and you can also have it in angle. So, and what that will do is it will create a motion that would be like a spline function here, or you can have a function like this. And we also saw how we can load the data from the file. Now, the file which I used was a text file. What I'm going to do is just show you how I arrange the data inside this text file. Now, the way I've done this is it has 2 columns, and there's a space between the columns. So it tells the first column is a time column, and the second column is your distance or angular velocity or acceleration. So that's how I created this text file and the data inside the text file. Right, that's all as far as the Simply Motion is concerned. And we have some upcoming training in the month of April. fundamentals class, other classes on advanced techniques and surfacing. All the updated information is on liveplm.com. Again, thank you for your time. If you have any questions, concerns, please email us, and here's our contact information. This video will be posted on our YouTube channel, youtube.com/liveplm.com. All right, thank you very much.